Okay, good morning, everyone. How's the sound? It's good, good. I hope you're having a great time here at the Copenhagen Developers Festival. Is it good so far? It's great, okay, good. So I'm going to be talking about React Server Components today. And first of all, why is that something you should care about? So we know that React and JavaScript is ever relevant, and with React Server Components, we have a completely new way to build React apps. Because React Server Components allow us to fade the boundary between the client and the server to create rich user interfaces with minimal client-side code while still maintaining interactivity and performance. So my goal today is going to be to introduce and motivate and provide resources about React Server Components. And before I start, first a little bit about me. My name is Aurora. I'm from Norway, and I work as a consultant at Meta in Oslo. And I'm a full-stack developer, but I work mostly on web these days, and I'm actively building with React Server Components in my current consultancy project. I bring to you my view as a developer joining the cutting-edge web world and how I'm learning and working with modern technology. The talking points of today will be first, rendering strategies. Then we'll get to React Server Components, what they are, how they work, and the benefits and the drawbacks. Then we'll go through the Next.js app router, onto best practices and patterns when using RC Next.js. And afterwards, I'm going to show you some examples of RC in a demo app that I've made. And finally, I'll give my thoughts on working with React Server Components in a real project and the future of RC. So let's begin with rendering strategies. You can't really have a talk about web development without mentioning them. It's a crucial prerequisite, and especially in this talk about React Server Components. So I'm not going to mention every type of rendering strategy and the history of the web here, but I'm going to go through some relevant topics. And this is probably going to be familiar to a lot of you. Static website rendering is the most basic rendering pattern where all the web pages are assembled beforehand and then uploaded as static files to a storage bucket. It can be built with plain HTML and CSS or combined with JavaScript. It's delivered exactly the way it's stored, meaning nothing will change unless the code is changed. And although quite simple and efficient, it doesn't handle dynamic data or interactive websites well, and it can be very impractical to maintain. A use case could be an informational website for business. You could say that this is the old way of making websites and is not used very much anymore. Multi-page applications, on the other hand, can handle dynamic data. So in an NPA, HTML and data is merged on the server per request and then sent as one package to the client. The user will open the browser and be served the merge result. And the entire page reloads per request or navigation to a new page. NPAs can be created with, for example, the ASP.NET MVC pattern, or with PHP or Ruby on Rails. Use cases would typically be an e-commerce app. For example, Amazon is an NPA. So what are the pros of NPAs? Firstly, all the page content can be read and indexed by search engines because it's rendered HTML, allowing them to appear in search results and be optimized for it. Then there is no restriction on the number of pages that you can add. Performance will be the same, meaning they have unlimited scalability. And lastly, they can provide more website insights. For example, Google Analytics can create reports for each page. The cons, though, they have a slower overall performance because they fetch each page as a package of HTML, CSS, and JS from the server as it's being navigated to. And next, since every navigation causes a full page reload, it can be hard to add real-time interactivity. And they can be hard to maintain as well because each page needs to be maintained separately. Then we have the single-page application, or SPA, also known as client-side rendering. A SPA will typically be a Create React app, a React app of Create React app, or Vite, or Angular Vue.js app. It's been the most common way to create an application for many years. So in a SPA, the bundle.js file includes everything needed to build the app. The entire HTML is created on the client when the user opens the browser on the app's URL. And the page will be blank until the JavaScript has been downloaded, parsed, and executed, and then the framework, like React, starts building it inside the root div, and finally loads the data. Then, after it's loaded, only data in JSON format is needed to update the UI. The use cases here could be any web app that needs to be highly interactive. What are the pros of using a SPA? They're fast, there's no lag, they've got smooth transitions and instant information present after the initial load. This is because everything is loaded initially and not re-requested per page as with an NPA. And second, they're easy to debug because everything can be logged in the browser because it's browser only, such as data, page elements, and network operations. And third, since everything is downloaded initially, they can work offline afterwards, cache data, and then update when possible. But there are some significant cons to using a SPA. Most importantly, they have a slow initial load because everything is, which is increased with everything that is added on to the bundle, such as additional libraries. And while you're waiting for this, you're just looking at a blank screen and then afterwards a bunch of loading spinners. Next, search engines like Google don't really know what's on the page because the crawlers read strings like HTML, so typically your SPA won't show up on the Google search results unless optimized in certain ways. And they need JavaScript to function, so therefore they cannot be progressively enhanced. And typically run poorly on devices with lower processing power. Finally, they cannot hide information from the client because the data only exists there, meaning things such as API keys cannot be stored in a SPA. For that, you would need a backend or a serverless function. So the key difference between a SPA and an MPA, or a SPA, in an SPA, everything loads initially, and then only data in JSON format is requested for making updates, whereas in an MPA, the entire page reload per request. I'm just going to get my water. I just realized I forgot my water. Do you have there? I forgot. I'll go with the water. Thank you. Thank you. So that brings us to SSR, which combines the advantages of an MPA and an SPA. So instead of generating the entire application on the client from the JavaScript bundle, server-side rendering means that you pre-render the initial pages on the server and then send them on demand. And this will let the user go to a URL and instantly see a fully formed page with components. And then they can start reading the content immediately without waiting for React to build the page. The JavaScript required to interact with the page is then sent alongside the HTML. In relation to SSR, we also have something called static site generation, or SSG, which lets us pre-render pages in the build process of the app, and then upload them to a storage bucket. The result of SSG is the same as with the quick and simple static website rendering, but we can generate the pages from, for example, React code. Server-side rendering is typically implemented in the so-called meta frameworks, which are frameworks around other JavaScript frameworks, such as Remix and Next for React, SvelteKit for Svelte, and Nuxt for Vue. So these frameworks are full-stack implementations of a web app, meaning they have their own server with things happening. Let's get back to that JavaScript that is sent along with the pre-rendered pages in SSR. So we still need JavaScript, thank you, to run on the client to handle any interactivity. So instead of conjuring all the DOM nodes from scratch, the framework, like React, will adopt the existing HTML. And this process is known as hydration. The framework will attach the event handlers and, for example, fire effects and add state. And then afterwards, the page is fully interactive. However, it essentially has to rebuild the entire tree and compare it with the existing one to know what to hydrate. So this quote by React core team member Dan Abramov explains it well. Hydration is like watering the dry HTML with the water of interactivity and event handlers. So that's pretty much SSR in a nutshell, done by a modern framework like Next.js. It lets you load the initial page quickly and then still have an interactive SPA. So this sounds great, but SSR isn't perfect. Because first, after the initial fetch of the HTML, the browser will download the JS code, parse it, and then execute it. And this causes the pre-rendered HTML to look fully interactive, but in fact, it doesn't contain any JavaScript yet. So the user is stuck in a place often referenced as uncanny valley, where they will click a button, but nothing happens. And the time until you can interact with the app might even be longer than what it would have been for a plain SPA version of the app. So why does this happen? First, you have to fetch everything before you can show anything. All the HTML with the data fetched must be processed on the server before it can be sent to the client. Secondly, you have to load everything before you can hydrate anything. That's because React needs to match the tree in the browser with the one from the server. And third, you have to hydrate everything before you can interact with anything. React starts the hydration and then doesn't stop until it's done. So there are many techniques being utilized in different frameworks to solve the hydration problem. Partial hydration can be used to define that only certain components need to have JS attached to them. For example, in the framework Astro, you can define which components to hydrate with a directive client load. And this is what we're going to be seeing in server components later. With progressive hydration, you can lazily load components JavaScript, for example, with Astro's client visible or with React suspense. Selective hydration lets you prioritize which component to make interactive first based on user interaction. This is also possible with suspense in React. And there's a lot of other ways being implemented in other frameworks, such as with resumability in Quick. Let's also mention the concept of streaming. So it's a part of the Fetch API of ES6. It's available in React 18 and is a big part of React Server Components performance. Streaming allows you to break down a request into smaller chunks and then progressively send those chunks from the server to the client, and then render each chunk as it's streamed in. And we can use it to send components down to the client as soon as they've been generated. So finally, with all that knowledge, we can move to React Server Components and how they solve these problems that we've been seeing. What if we could decide when we needed the behavior of a SPA or an MPA all in the same stack? And the code I'm going to be showing here will be, you can see it again in the demo later. So what are they? React Server Components are components that run exclusively on the server. Server components never re-render. They run once on the server to generate the UI, and then their JavaScript is never sent to the client. And when you say rendered on the server, I mean the server that is part of the full-stack framework, such as Next.js, or during the build of the app, not some .NET REST API. This is the front-end's own backend, which in many cases eliminate the need for writing a REST API. Server components differ from server-side rendering because they are never hydrated, meaning the resulting app is partially hydrated. Hydration to non-RCs components can happen concurrently while RCs are streaming in, since the compute load is shared between the client and the server. And since RCs are exclusively run on the server, we can write database queries right inside our components. So here's an example of a simple server component called JokesList. I can query my database through an ORM like Prisma and have the data available and component fully rendered before it's sent to the client. Server components also introduce this type of async component, basically an async function, that can asynchronously fetch data on the server without causing any issues for the client side. And you can do any kind of data fetching in here, such as calling your API. Because React Server Components only run on the server, this means that a big chunk of React's API is incompatible with them. For example, we can't use state because state can change, but server components can't re-render. And we can't use effects because effects only run after the render on the client, and server components never make it to the client. We also can't use any browser-specific APIs because they don't exist there, such as window.location. And we can't use onClick and onChange because they require JavaScript. So server components themselves are simple, but the React server component world is more complex, because we still want to have interactive components that include state and effect and event handlers. So because of this distinction, there are now two types of React components: server components and client components. And the client components will be the normal React components that you can do whatever you're used to inside. But it's worth noting that they're still pre-rendered on the server during the build and then hydrated on the client, as with the pre-existing SSR. So to make a client component, you must mark them with use client. And that's how you define that you can use things like state and effects and onClick as normal, and that this component will have its JS in the browser. So here's an explanation from the Next.js app router docs on the limitation in server and client components. If you need to fetch data, access backend resources, keep sensitive information on the server, or keep large dependencies on the server, you would be using a server component. And if you need to add interactivity like onClick or onChange, or use state or effects, or use browser-only APIs, you would be using a client component. How do they work? What happens is that React renders server components into a special format called the RC payload. And this is a streamable format that represents the DOM. It's kind of like a serialized version of a React tree. And the RC payload contains the render server components with holes of references to client components and the props they pass down to them. It is being used both to generate the pre-rendered HTML on the server and to update the DOM on the client without a need for JavaScript. So here's what it looks like in the console. We have the initial server-side rendered HTML of the page, as well as the RC payloads, which is identifiable by the _RC name, and multiple client-side JS bundles. And these are all used together to build the interactive page. And since this component is defined as server-only, it doesn't need to be hydrated at all, and its JavaScript is never shipped to the client. As with everything, it's quite complex when you start digging, so that's OK for now. When an RC needs to be re-rendered due to the data being changed or has to be updated, it refreshes on the server and then seamlessly merges into the existing DOM without a hard refresh, updating only the parts that have changed. As a result, the client state can be preserved even as parts of the view are updated from the server. And this is possible because the RC payload only contains references to the client components and doesn't have to do anything with them. What are the benefits of using React Server components? Firstly, data fetching. Data fetching can happen in components before they're sent to the client and will be faster since they can call the API or database in proximity to the resource. And inside RCs, you have access to all your backend resources. Next, they can ensure security by keeping sensitive data and logic like API keys on the server and never risk exposing them. Then caching. So by rendering on the server, the result can be cached and reused on subsequent requests and across users. And bundle size. So server components allow you to keep large dependencies on the server, meaning you can exclude all the JS for those components from the bundle without restricting your use of them. For example, a heavy library like Lodash, which will overall lead to a more performant application. Server components can furthermore be streamed, meaning they can be sent in chunks as viewed as they become ready. So therefore, they integrate naturally with React 18 Suspense. And finally, developer experience. There's a lot less hassle on the client side with effects and keeping data in the state. Just fetch it async off the client. RC, however, comes with some drawbacks. First, they require a framework. In practice, you will only be using them in a meta framework like Next.js due to their need for a certain bundler and router setup, which means you will become bound to the framework's way of things and you have to follow their rules. Second, they create increased complexity. So as a web dev, you now have to understand a lot more concepts than before when you were just making a spa with Create React App, such as what you can and can't do on the server. Next, it can be hard to onboard new developers because the learning curve is a lot steeper when aiming to write quality apps. And finally, it's still relatively new and not everything has been figured out, such as testing and compatibility with other libraries. For example, many CSS and JS libraries like Emotion and Style Components don't work with RCs. So for that, we need to use alternatives like Linearia, Panda CSS, Material UI's Pigment CSS, which is a new library that's aiming to solve this problem. And there's been a lot of bugs in the app router since it was marked as stable, but it's really seeming to settle down now. So how do you get started with RCs? The most reasonable way right now is in the Next.js app router, available from version 13.4 and onwards. And Next.js is made by Vercel and is battle-tested and enterprise-ready. React Server components are a part of React 19, but developed closely with Vercel and Next.js, which is good for building apps with them because everything is optimized and working smoothly. And you have the entire React ecosystem following. So to make a Next.js 14 app, run this npx create command and define whether you want TypeScript and Tailwind and such. And you need the app router option set to yes to use RC. So that will generate the boilerplate for you, and you can start using them right away. There's not a lot of files here to confuse you. It's mostly standard files such as package, JSON, or tsconfig, and some config for Tailwind and ESLint. So what matters here is everything inside the app directory. In the app router, you define routes by making folders containing a page TSX. That's what makes it a valid route. So in this example, I have some routes. It's /jokes, and then a /new, and a /joke ID subroute, which is a dynamic route, because it's based on the ID that you're currently on in the URL, which is meaning it's a parameterized route. And then you can also use files with reserved names, such as notfound.tsx, error.tsx, which are error boundaries that render inside the layout of the route, as well as loading.tsx, which creates a suspense boundary around the page. And all of these can be granularized. You can add them to the root or to subroutes or wherever you want. And there's more features like ignoring folders from routes with underscore or grouping them with parentheses. You can also define API routes in here, like in the pages router. So the route.ts file is a reserved name and will allow you to create API endpoints. And then there is support for SEO with, for example, meta tags. They can be added to any page or layout and can also be generated dynamically, for example, using the route params. So with Next.js comes a lot of optimization, such as caching. All the pages generated in the build can be cached on Vercel CDN if you host it there. And there are additional caching mechanisms like the router cache, which caches RC payloads. And all of these can be enabled. And there's also built-in code splitting for lazy loading JS. And Next.js will optimize your images if you use the image tags and do things like preload pages when a user hovers a link. And it has built-in font optimization. So how do you use React Server components in Next.js the right way? What are the best practices and development patterns to get the most out of them? The best practice is going to be to move your client code to the leaves of the component tree. In this way, you ensure you do not ship any necessary JavaScript to the client. And then React will only hydrate these client leaves, as we know, as partial hydration. You could, in theory, just put use client on your root and then code however you want, but that just means all your components have their JS shipped and be hydrated, which just takes us back to the standard server-side rendering. But this doesn't mean that you have to be afraid of using client components. It's completely normal to have bigger client component sections when there are parts of the app that are very interactive. To use a client component in a server component, you simply import it. So here, the delete functionality has been extracted to a component with useClient because it needs an on-click event handler. However, when going the other way around, you cannot do the same without turning the server component into a client component. You instead need to slide it as a prop, and they will fit as separate chunks into the client tree. And the client component doesn't really know what's being passed down here, and this can be referred to as the donut pattern. So this means that we can make a tree that looks like anything we want, and we can add client-side logic in the parent components as well. Here, only the green components are hydrated and contain JS. The rest is just HTML. With this pattern, we can furthermore implement things like state management. So by providing a wrapper client component with state, for example, using React Context, which only works on the client side, we can use the state in the leaves without converting the server components in between. And when combined, this allows us to make apps that are extremely performant due to their large amount of non-hydrated content, while still being fully interactive. You could have a donut pattern collapsible sidebar, a theme toggle provider, a search, and then buttons on the client side. And then you can share your state between components however you need. When building an RC component tree, there will be some limitations between the client and the server components, though. So for example, since the client components exist on the client and the server components on the server, props need to be serializable because we are crossing the server boundary here. And that means that we cannot pass functions through the server boundary. So instead, we need to create API endpoints to communicate between them when we can't use props, or React server actions to simplify the process, which I will talk more about later. So how do we manage our data with RC and the app router? I already showed that you can make database queries through an ORM like Prisma, but you can also use the fetch API, and there are a bunch of parameters here that you can add, such as cache duration, tags for validation, and revalidating the data and headers and more. And in this example, I'm showing what you could potentially do, for example, getting a cookie and making an authenticator request to an API. And getting data this way in your server is efficient, because on the server you have this privileged environment with everything you need accessible. And if you use the same data in multiple components in a tree, you do not have to fetch it in the root and then pass it down. You can fetch it in each component where it's required, because it's automatically deduped. And you can compare this pattern to React query, where you will call your hooks wherever they are needed, and they will all call the same cache data. And in addition, you can pass it down to client components when you need it, for example, as the options of an autocomplete component. So what about data mutation? I mentioned that you can create API endpoints like in the Pages router, but let's skip that for now and look at something way better called server actions. Server actions just became stable with the release of Next.14. We are, by the way, almost at the 15 now. And they are the preferred way to mutate data. They kind of complete the whole server component story. So it's pretty simple. You mark a function or a file with useServer, and then Next.js will make a hidden API endpoint for you, allowing you to call it from anywhere, like from a client component, which solves this problem of passing functions between the server and the client. And in addition, you get type safety between the server and the client through RPC. So here I have a file marked with useServer, turning the function inside it into a server action. And I can now call it from a client component. And that's basically all I need to do. But I also need to tell Next.js that I have changed something in the data when I've done my mutation, so that it can regenerate these server components. And I do that by saying revalidate path, which will validate the view, fetch new data from the database. So looking at our data management graph here, the server action seamlessly takes us back from the client and to the server again. Server actions also integrate nicely with form submissions. So in this example, I have a form and a function marked with useServer. And when submitting the form with the action property, which is a part of React 19, being called this way with a function, it can, without JavaScript, call the server action and add a joke to the database. And again, I have to tell Next.js to revalidate the view. And there's so many possibilities here, and it's extremely efficient to develop with. Finally, here's an example of something I have made for my current consultancy project where we use RC. So in this example, there's a client component collapsible container and a server component fetching data, mapping to server component messages, and then an interactive client component, input field, submitting with server actions. And there's also a wrapper here to handle the automatic scroll. So in this example, I'm weaving the server and the client together, meaning everything that does not have to be on the client can be only on the server. So that's pretty much it. React Server Components in the app router allow you to do whatever you need to do, whether it's MPI functionality or interactive SPA stuff, or include SSR or SEO or any kind of functionality you need, all in the same stack and optimized, which is pretty amazing. So hopefully you remember some of these terms by now. It's a lot. And React Server Components will kind of force you into this new mental model and architecture. So let's get into a demo of this joke app. It's a remake of the tutorial app from the remix docs, but of course very different because it uses RC and Tailwind and server actions. And it's also containing very simple implementations so that the code is not clogged with complexity for the sake of the demo. So the setup here is, of course, Next.js app router and Tailwind for CSS and responsiveness. And then I'm using Prisma as an ORM and an Azure SQL database. So I'm on the main page here. I'm just going to jump to the joke page. And in this page, you have a list of jokes that you can view. And then you had a button to add a new one. Programmers, for example. Why are assembly programmers always soaking wet? Because they work below sea level. So let's add that one. It's pretty good. So I can add it, and then finally, I can also delete it. And that's basically the whole main functionality of the app. So let's look at the code for this. So in this, this is the app router, and there's the boilerplate that you saw earlier. And then there's some Prisma stuff, form validations, the public folder for public assets. I have a lib folder here with my data access layer, components, and UI components, and finally the app router. So if we look inside the app router, we have the layout here, which there's nothing inside, and the page, which is this main page here. And this is all server stuff, no interactivity needed, just HTML here. And then I can go to the jokes route, which is here because of this file-based routing. And the layout here is containing a header, a sidebar, which is now in the middle because of the responsiveness, but still, and a footer. So let's just have a look at these. So the header is only containing links, no interactivity, it can just be on the server. No JS on the client for this one. Then there is a footer, same thing here, just links, nothing special. And then the sidebar. So that's the footer here, by the way, sorry. And this sidebar, which you will see is a sidebar in this normal view. And it's containing a random joke button, this one here, the jokes list component, and a nav button. So let's begin by looking at this random joke button, which is just getting a random joke. And this is using a client-side hook use router to refresh the page. And that's why it has to be a client component with this use client directive, meaning the JavaScript to make this work and this onClick possible is shipped to the client. The jokes list component is fetching its own data. It's async, and it's awaiting a database call. And it's a server component because it's accessing our database here. And let's look at the function. It's just finding many jokes from the database here on the server and mapping them to links. And the nav button is still, it's also just a server component with just a link. And we can actually go to this route and have a look at the new page here. So there's a page, makes it a route. We have the new here. And I'm just going to do this again so you can see. And it's going to add, add a joke there. And this is using the form action property to bind to a server action here. And this server action is defined with useServer, meaning we can use it from anywhere with this hidden API endpoint defined or created by Next.js. And it's mutating, or it's adding a joke to the database here. We're validating the path to regenerate the jokes list component and then redirecting to this joke. And there's also an add button, because if you noticed that I have this interactivity while I'm waiting here, it's saying adding. So that's why it's a client component, because it requires real-time interactivity. And it's using a new React 19 hook called useFormStatus, which will get the current state of the form that it's inside. And this can be used to make way better components than this, maybe something like a generalized submit button with a spinner, something like that. But in this case, it's very simple. Then finally, the joke ID route, which is when you're currently selected a joke here. This is the ID, and it's a dynamic route with a page, which is generating some metadata here dynamically. That's why you can see it says arrays joke at the top here. So it's getting a joke based on the params, from the database, and throwing a not found if it didn't find anything. And then it will display it with the content, and it also has this delete joke button. And by the way, if a not found is thrown, you can handle it with a not found error boundary, or if there's a different error, it will be in the error. I can actually show that to you. So this is not found. OK, so it rendered our not found error boundary here. There you go. And there's a loading, so that when you click something and it's waiting for it to load, these are already cached, but it will display this skeleton. And the delete button is also giving me this interactive feedback, which is, of course, a client component to be able to do that, because this is a JavaScript thing. And this is using a server action, because we're on the client, we have to get to the server, good thing we have server actions, to delete a joke based on an ID here with the useServer directive. And it's also using a transition, which can be async as a part of React 19, which will give us the pending state of whatever is inside. So that's why I'm seeing this deleting here. That's it for the main part of this app, but I have made some additional demo routes here to display some of the other concepts I've been explaining. So let's have a look at those. So I'm going to head over to, so I have this demo route here with lots of routes. And this is displaying the donut pattern that I showed in the slides, how you can nest them. So you can do server component, which is the main one here, client component, server component, if you slot it as a prop like this. So the client component doesn't really care what's being passed down. It's just doing its thing. And the server component has already been rendered on the server. And if we have a look in the console, the server component is doing outer server, console log, inner server, and this is logged on the server. And in the client, when I click, let's see if I can get some more space here, it will only be logged on the client here. So this is the kind of way you can nest them together. The next route I want to show you is an example of revalidation. So I mentioned that when you can refresh an RSC, it doesn't remove the client state that you already have there. So if I'm creating some client state here, and I'm going to add a new joke, it will not destroy any of the client state that's already there in the page. And it didn't do any hard refresh or anything. Next is how to do global state management. So typically, you can use React Context with a theme provider. You would have a theme provider, and then you can have pretend this is like a big tree, server components somewhere, some client components. And they can both use the provider across the server tree here with a set theme component, which is using provider to set a theme, and a use theme component, which is just using the theme. So even though there's server components in between here, we can still communicate across it. And you can also use the stand where if you don't need the provider features and you don't just want a global state. I also have a couple different examples of forms. So first, to show you what it's like when you do server-side validation. So if you were to have a form that would do something on the server here, this is a server action. It's making sure that it's a certain length with this schema here. If it fails, we can see that it's being logged on the server here. So we have the validation error here because it's happening on the server. And you can also do validation on the client side, which same thing, but we're on the client. So this is use client, client component. And if it fails to validate, it will be logged on the client instead. There you go. And this can be combined to, for example, make a super interactive React hook form, which has client-side validation and server-side validation, and it can even be optimistic. So let's just have a look at that. So I'm using the typical React hook form hook here. I'm using a new React 19 feature, use optimistic, and doing some stuff here. But really what I want to show you is that we can have our React hook form interactivity here, which you might be used to seeing. And I'm going to click add, and it will be optimistic, like that, boom. But if there's an error, so it's going to fail now because I have a different validation on the server, it will just roll back. And there's also another new hook that I want to just show you. So I call this action state form because it's a new hook called use action state. And this is something that's from React 19, which can let you do form, get return value from some kind of form mutation without JavaScript, if you want that. So if I were to turn off JavaScript here, it would still work. And I'm returning the validation from the server here, using use action state and create joke. Then I've been talking a lot about suspenses. Because When you're waiting on something on the server, typically dynamic content, you need to show a fallback. So what's happening here is something is being awaited on the server, and I'm rendering a suspense fallback. And the way this looks like is that I have a loading TSX, which is the suspense for the full page, because this is awaiting just a slow function, which is just a promise. And then I have another suspense around this header, because it's also slow. And then there is another jokes here inside suspense with the list, and then this function is slow. So pretend there's like different levels of how slow your requests are from the server, and it's dynamic, so you have to do something in between. And that's when you use a suspense to render a fallback like this. And even though I'm waiting for something, I can still interact with this page, even though the server isn't completely done with what I'm doing here. React query is also worth mentioning, because if you want, you can still do your normal client-side fetching, and you can also make a kind of like a hydration boundary, which lets you define a server state first, so that it doesn't get any spinner here. And then finally, last route here, you can also attach server actions to blur events. For example, here, I'm doing something on blur, and then calling server action, and then you can do like something like auto-save features from the client to the server. OK, I think that's it for the demo. I'm going to head back to my slides now. There we go. So this is the Lighthouse score of this joke app, which is not really optimized a lot. I just followed these patterns. And it's a very small app, but you still get the point. And all in all, you can build very performant apps by default, where the limitations of RC will make your code better, unlike in plain React, where you can do whatever you want. And here's also the badge for the app, where when sharing a link to a joke, as you can see, the dynamic meta tags create a badge. So the next topic is some real-world experience with this. So I'm working with RC in my current consultancy project. It's a medium-scale production app with, and so let me just talk a little bit about my requirements and my experience so far. I'm working on a project set to last at least 1 year, and it's a rewrite of an existing MVC app with a lot of technical debt. So the app would contain interactive dashboards, complex forms, articles through a CMS, and a lot of static data, and a need for SEO. It also needs to be mobile-friendly and accessible and support multiple languages. And a big part of the app, and something I made sure to proof of concept with RC before choosing the framework, is the customer's design system component library. And first of all, this app is a great case for RC because it can server-side render a lot of content, but then also be highly interactive when it needs to be. And I'm finding it to work well so far. However, I have had to do quite a lot of trial and error and research to build functionality that is non-standard. So for example, I had to create wrapper components for the customer-specific component library to be able to use them in my project and then put server components inside them. I also had to pick my internationalization library without much guidance from Next.js. It's working well, but there were certainly complexities. And then finally, testing RC is not covered properly anywhere. They basically just tell you to use end-to-end testing, and then don't say anything else. And so to test async components with a component test with RTL, you have to follow this workaround and kind of do your own research there, how to do it. But all in all, it's going really well, because the app is performant, it fulfills the requirements, it's maintainable, enforces best practices, and it's a really great developer experience. And the Next.js app router with RC inside provides so many tools to let me focus on building my apps. So to finish this off, what is going to be the future of RC? There is no doubt that this is the way React is going now. It's not just some hype cycle that will die out. It's the result of many years of work from the React team. So for example, Vercel is actually in the progress of migrating their own dashboard to the app router. And in this tweet, the CEO of Vercel talks about the significant performance benefits they're seeing. And there's a lot of examples coming out constantly of more and more projects transitioning, migrating to the app router or creating something new in the app router, and they're seeing really good results. So we just have to keep paying attention to this and see if there are more success stories. And finally, see the result of this migration when they're done with this, to kind of get the proof here. And there's also multiple other frameworks that are implementing RCs, such as Remix with the announcement of React Router v7, and the framework Redwood.js, and most recently Expo for mobile development. So big things are happening. There are so many solutions being proposed to improve the performance of web apps, with the goal of finding the optimal balance between UX and DX. And this is React's take. So nonetheless, there's a lot of things to be figured out as React Server components are battle tested. So here is the repo for the joke app. Everything is there, as well as the reference demo pages. And there's also some more resources here that I used during my RSC learning experience. The React and Next.js docs are good. And you will find more client-side stuff in the React docs, and then a more server approach in the Next.js docs. And of course, Next.js-specific stuff. And there are a bunch of template apps by Vercel that you can reference. And there's a recently released free course called Learn Next.js, which will take you through the whole experience of building an app from scratch, and then finally deploy to Vercel. For YouTube, ByteGrad does a lot of thorough RSC content. And Code with Antonio does some incredible clones of apps like Twitch and Miro and recently Slack with full YouTube code-alongs, like, I don't know, 14-hour code-alongs. And he just recently started taking payment for the code, but you can still watch the videos and see how he does things, because he's really good at this. So I recommend these. And thanks for listening. I hope you're excited as I am. I have some social media here. I blog about RC, and I have a Twitter where I post stuff. And I'm going to post my slides there. Yeah, some of the posts I have are about these React 19 hooks in specific, making a reusable submit button, testing RCs, and integrating with React hook forms, and more. So thank you. We can do some questions here, or if you want to walk up later, that's also cool. Yes? Maybe microphone? Do we need that?
I can try shout.
I can just repeat the question. Go ahead.
What's the hot module like reload like for the server components? Like when you're saving something, pay to re-render that when you're developing?
It's instant. It's just like a normal React app, like Vite. It's amazing. It's really great. Yes. Anything else? OK. Thank you. Thank you for having me here.